Okay, now we're in the schoolwork. This is a formula that you're going to be paying attention to whenever you're doing testing. For every 1 pound of material you run, for every milligram of gold you recover, indicates 2 grams per ton of gold, or what you're looking for, in the head ore material that you ran. So here's milligrams divided pounds run times 2. That indicates grams per ton. It's a good formula for pounds. You can even smelt and get the same results, and it tells you the same thing. Okay, the tables that we produce, you need to think of them differently than you do conventional mining. Because there's basically 2 questions you have to answer to figure out what you're going to do. And that's the number of tons per day divided by the hours you're going to run. So if you're running 24 hours a day or 10 hours a day, so what you're going to do is how many tons do you want to run, and you want to know that number in hours. Again, 10, 5 to 8 tons per hour. So this is your head ore. So we want to know how much you're going to run. So that tells you there. Now, you've been testing with the M7 and you've found out how much gold you have per ton of that material. Let's say you're running 1/4 ounce material. By the way, precious metals is always weighed in troy ounces as opposed to avoirdupois ounces. This pounds of material you run is avoirdupois. The grams is grams. Doesn't make any difference what you're weighing it in. But when you're talking about ounces, precious metals are always in troy ounces, which is 31.104, and that keeps on going like that. So we're testing, and we've tested, and it shows that we have 1/4 ounce per ton. So now we need to know is how much do you want to run, or better yet, how much do you need to run to be able to make it economical for you to do that. If you're a small operation, you can run 25 to 50 tons a day and make it economical with this, because if you went 20 times 1/4, that's 5 ounces a day. At $1,300, that's $6,500 a day. So now you got to figure out, is that enough money to make the mining operation feasible? You got to figure electricity, gasoline, diesel, time, all of those things. How many people you're doing. So what we need to do is figure out how many tons we want to run in a day. Once we know that, then we can figure out how much you need to run on your primary concentrator. So we have primary, trader. So now we know what that is. Now the next question you need to ask is, what are you going to do with your cons? How much concentrate can you handle? Are you going to smelt it? Are you going to leach it? Or are you going to sell it? If you're going to smelt it, then this is determined by how big a smelter you have. Let's say you can do a smelter that does 50 pounds an hour, or a 50-pound batch at a time. So if it can do 50 pounds per batch, and you can run, let's say, 4 batches per day, then you can have 200 pounds per day of concentrates. This is just a ballpark figure here. If you have a bigger smelting operation, you can do more material. I am going to get as much concentrate as I can run. In other words, just because I could run this 20 tons down to 20 pounds, which you could if you wanted to. So if you run 20 tons down to 20 pounds, that's about a 10,001 con. But I have a smelter here that does 50 pounds or 4 batches in a day or 200 pounds. Why am I working, and I'm going to have losses to be able to get down to this 20 pounds. I'm going to be throwing away some gold between here and here to do that, when I have the equipment to do this with just at most a couple of points of loss. This is what we need to look at. So these are the 2 questions you have. You have your first one is, how much do you want to run in a day? And how much can you handle in concentrates a day? Once you know those 2 figures, then it's easy to tell you what to do with the equipment. Because I'm going to run my primary concentrate somewhere between 10 to 1 to 20 to 1. I'm going to run it that much because I want at least 80 to 85% recovery. I may get more, but I don't want any less. So here's the figures I'm looking at. So if we do a 20 to 1 concentrate, that means at 20 tons, I have 1 ton of primary concentrate. Now, with the last figure, I can handle 200 pounds. I may not want to handle 200 pounds if I'm going to only have a ton of material, but I can handle that. So I may take this 1 ton and take it down to 100 pounds. And this is my smelt. That means that I've gone from 40,000 pounds down to 100 pounds. It's a 400 to 1 con. I've cut this down, this 20 tons down to 100 pounds. Now, at this point right here, I'm willing to lose 80 to accept 80 to 85% recovery, if more. At this point, I don't want any losses. Because now I'm only dealing with a ton of material that if we added a 1/4 ounce, it has 5 ounces per ton. That's 5 ounces, I want it. So I'm going to cut this where I need to get down into here. If I need to do this on like just one more M7, that's what I'm going to do. If I have to get it down, and let's say, good example, Brazil. We were running 50 tons an hour, 50 tons in a day. But they could only handle 2 kilos per day. Two kilos is 10 pounds. Give or take. Out of 50 tons. Well, at 20 tons, at 100 pounds, we got a 400 to 1 con. At this one here, we're looking at 100,000 pounds down to 10 pounds. That's a 10,000 to 1 cut. We lost some gold here. But the ability for them to be able to handle their concentrates was this figure. So that's the one that we had after we got this primary con run. This was the final figure we had to look at. And as I was saying, this is what you need to do. So with these tables, you look at how much you need to run, you look at how much you can handle. Once you know those two figures, the equipment will do that for you. Right here, I would not, in most cases, if I was running 20 tons a day, and I could cut it at 20 to 1, and I could do 1 ton out of there in a day, and then I would run it on a table and do that. I would not do that. I have the equipment and the ability to run 10 to 1 con, run this up another 10 or 15%. Well, we wouldn't run 15. Let's say we could get up to 90 to 90, can't write 9, 95%. That's going to be, that's, I wouldn't even think about 95%. But I could run it up another 5 to 10 points. And if I can do that, I have the equipment and the ability to do that. So why am I going to get in a hurry and try and get this when I could do this really easy? Run this down into our primary cons, or our finished cons, and do this. It's what you can do. Anyway, this is the two figures you need. Is what am I going to do as my primary con, and what am I going to is my finish con. So that's the two figures. We're not going to have any more product than that. We're going to have a product that is over here on one side. If we're picking up this side over here, these tails are something I am not even going to look at again. It means they're so low grade that it's not worthwhile. Here I'm going to make sure that I am getting my 0 or less. This one is for economics. This one here is so that you can say to yourself, I need to run this amount of material, and I can get this much material, this much value out of that material. This is what I need to run. This one tells you, after you've run it, what am I going to finish up with? How am I going to handle the concentrate? Once I get to this one, now all I have to do is figure out what I'm going to have to do it. Hopefully nothing like this. Instead of 20 tons a day, we want 30 tons out of it. But instead of getting a quarter troy ounce per ton, we're now down to per ton. So now I'm leaving and if you multiply that by $1,300 an ounce, you come out with $65 a ton. $65 a ton is starting to push. We can almost make money if that was all I had in there, I wouldn't run the ore. But if I'm running the ore anyway, $65 is too much for me to lose. So what I've done now, instead of running my 20 tons, I run it up to 30 tons. I'm leaving $65 worth of gold per ton. Now instead of having 2 cuts, 1 tails and 1 con, I now have a tail that's 0.05. Now I want to start thinking about running this again. What are you going to do? Why are you going to think about that when you were up here and you were getting all of it, or as much as you could get? This is from I just want gold to I want a profit. Now, if we were doing 0.2 and we run 30 tons a day, that is 6 troy ounces a day of gold. We were doing 5 ounces up here. And we never have to think about this. If I wanted another ounce of gold, all I have to do is run 4 more tons of this to do that. So what am I doing is I'm running 10 more tons and I'm losing money. Or I'm throwing money away. So these are the considerations. You've got to look at this. Now, if I was running 30 tons a day and I was getting a quarter of an ounce, and then I slowed it down to 20 tons a day and I was getting maybe 0.27, economics aren't there. I'm going to throw that 0.02 away. That isn't enough. 0.02 is $26. So we're looking for the number where we get the maximum amount of material, the best recovery for economics, and that's what we're going to run at. Okay, we've gone through all the things that we're looking at. How much you need to run, and what you can handle at the end of the day is concentrates. If we know that, and let's say we want to run 20 tons per hour. It's a small operation. And that's an operation. If it's a hard rock, that's a lot. If it's a dig and screen and maybe crush, that's not too bad. The more time it takes you to process your ore, the higher grade it has to be. Hard rock oh, even today, I would like to see a minimum of a quarter, preferably somewhere a half to 3/4 of an ounce per ton that I'm running in a hard rock operation, because we're drifting in, we got to do a lot of work to get there. If I'm in a placer operation and all I'm going to do is screen, I can look at a gram or two a ton and make it worthwhile, because I'm not handling much. If I have to grind, 3 to 4 grams a ton is what I want to be looking at. But let's say we've got it all figured out and we want to run 20 tons per hour. My equipment, on the conservative side, not the best conditions. On the conservative side, if we say the M10 will run 5 tons per hour, we need 4 of them. This is the worst case scenario. Good ore that's ground somewhere around 50 to 100 mesh, it's quartz, doesn't have very much clay in it, you're probably going to be running around 8 tons per hour. But let's start here. Okay, now, how much concentrates can you handle? This is the next question. This is your first question. Second question, how much can you handle? Normally, on this big of an operation, you would be running M10, two M7s down to 1 M7. So that I'm running 5 tons, I'm running 1 ton, or let's say 1,000 pounds, and then I'm running 100 pounds. And then I'm going to cut this at wherever I need for that smelting operation. So if this is the worst case scenario, and you have you have to have 4 of them, you've got 4 setups. Just like that. So 4 of those are going to run you somewhere between 20 and 30 tons per hour. And like I said, how big a smelter do you have? Or what are you going to be doing with your cons? That is determined by these 3. This one is determined by that. These are determined if you're smelting, size. How much can you handle? Anyway, and if you're running this properly, these tails over here are not a question whether you're going to look at them again, because I'm not. The same with this one. If you're running this at optimum size, these tails are not a question. There isn't enough gold in there to worry about, because you're running these properly. Now, this 100 pounds here, the tails off of that, it just depends on what you're doing, if you're doing it right. Now, when I say that, I'm talking about recoverable gold. I'm talking about gold that's in particle size, or either that or tied up with your sulfides. If it is soluble gold, gold chlorides, gold oxides, any of the fancy golds that you can have out there, if they don't gravity separate, the table's not going to catch them. If you come up here and you assay this, and I say fire, I trust fire assays if done properly. ICPs have a wish factor. And see now, wish factors in mining usually cost you lots of money. I don't like ICPs. ICPs are very good for telling you what else is in there and what the possibilities are. But they won't tell you if this gold is a gold chloride, because it's probably gone when they do that. Or they may be getting all the gold chloride. It's reading really well on their ICP. They have calibrated and everything's running well. Well, it's showing a bunch of gold chlorides or something equally interesting. Well, this ain't it. This ain't gonna work. Now you're into leaching or something equally interesting, which is very expensive under the best conditions. A fire assay, if you can fire assay it, it is recoverable gold. You can get it. Now, you can get into a little bit of trouble here if, say, you have some golds that were soluble, but you dried out the whole mass. In other words, the liquid and everything. Well, now you still have that stuff because you dried it. And now you fire assayed it, and it hasn't got any, it shows that gold up. So what we do is we do a concentrate and then we do it from there, and that gives us our fire assay. Good luck. Do your homework.